Okay, example number 4, dy dx equals y cubed plus 2x, where y is the function of x and f of 1 equals 2. That condition tells us that the ordered pair x is equal to 1, y is equal to 2 falls on the curve, falls on the function. The question wants us to find f prime at 1 and also wants us to find f double prime at 1. Perhaps your first gut is to say, well, I'm going to find that function and then simply find f prime of 1 and f double prime of 1. The problem is this differential equation is not separable, and right now you don't know how to solve this differential equation because you cannot successfully separate the variables to get y and dy on one side, x and dx on another side. But there is enough information here to answer the question. So let's take a look. I'm going to change the notation here for a minute and call this f prime of xy to equal y cubed plus 2x. See, the slope depends on the x and the y. So now if I want to find f prime at 1, that's the same thing as saying finding f prime at 1 and the corresponding y, which is 2. So I need to plug 2 in for y and 1 in for x, and that tells me that f prime at 1 is equal to 10. Now f double prime of xy can be written as d squared y dx squared, the second derivative, which if you recall is the derivative of the derivative, which is the derivative of, and we said the derivative in the beginning was y cubed plus 2x. So I will employ implicit differentiation, 3y squared times dy dx plus 2. Now at this point I could in fact take what my dy dx is and plug it in here, but all that I need is the numeric value of dy dx, so I will skip that and say that f double prime at 1 is equal to f double prime at x equals 1, y equals 2. Here's where I can skip it because I can say where dy dx is equal to 10, which was solved earlier. So now I have 3. I plug 2 in for y. I plug 10 in for dy dx. And then I add the 2. And that comes out to be 122. The second derivative is 122.